Dyson spheres are like huge structures that could wrap around stars to get their energy. Even though we haven't spotted any in our galaxy, scientists are looking for them and other signs of alien life. It's a mix of real science and imagination that makes us wonder about what's really happening out there in space. Physicist Freeman Dyson initially formalized the idea in 1960. However, earlier science fiction served as an inspiration. A Dyson sphere is not necessarily a solid shell. It is a cluster of solar collectors, or satellites, in tight orbit around a star. The objective of a Dyson sphere is to gather as much energy as possible from a star. NASA's Solar Radiation and Climate Experiment has shown that the amount of energy that Earth receives from the Sun is 1,361 watts per square meter. However, the Australian Space Weather Forecasting Centre states that this is only a small fraction of the Sun's total energy output, which is 380 billion quadrillion watts per second, emitted in all directions. We receive only a small amount of this energy due to the small size of Earth. With the construction of Dyson spheres, the civilization might possibly support its long-term existence and scientific growth by capturing almost all of the energy generated by its star. Many theoretical models have been inspired by the idea of a Dyson sphere. The designs, levels of complexity, and possible applications of these models vary. A group of solar-powered spacecraft circling a star is known as a Dyson swarm. These satellites use microwave or laser beams to transfer solar energy to a central location. Like a Dyson swarm, a Dyson bubble is made up of a huge number of satellites that are kept in place at a specific distance from the star by solar sails. By encircling the star in a spherical shell, these satellites absorb its energy. A solid continuous structure that encloses a star is called a Dyson shell. It absorbs almost all of the energy that the star emits. Dyson net is a loose, net-like structure surrounding a star, created by a network of linked solar collectors. A single band or ring of solar panels circling the star at a particular distance makes up a Dyson ring. Constructing a Dyson sphere is currently pretty far beyond our technical capabilities. Keeping with the technological feasibility, the following are primary factors to take into account. The durability and strength of material to be used in Dyson is the main concern. A Dyson sphere's construction materials have to be able to withstand harsh circumstances, such as intense heat and strong gravitational pulls. As of right now, no known material possesses the required balance of radiation resistance, strength, and lightweight. Developments in nanotechnology or the creation of new materials like graphene, which is known for its exceptional strength and conductivity, may provide answers. Massive energy consumption is another factor. It would take a lot more energy than we now have to build a Dyson sphere. Mining, transportation, and assembling materials on this scale requires enormous amounts of energy. Although it's still in its early phases of research, fusion power could be an achievable source of energy for this kind of project. Von Neumann probes, or self-replicating machines, could be used to manage the construction process more effectively. These self-sufficient robots could mine materials, produce parts, and put the Dyson sphere together. Though there are theoretical ideas for these machines, actual implementation is still quite a ways away. Different organizations and research centers are putting their efforts in construction and searching for Dyson sphere. Search for extraterrestrial intelligence is a top priority. Their main goal is to find techno-signatures, which are the indicators of technology from extraterrestrial civilizations or aliens. Finding a response to the important query of whether or not we are alone in this universe is the main objective. Through the analysis of data from a variety of astronomical surveys, scientists hope to find anomalies that might point to the existence of advanced extraterrestrial civilizations that might have constructed Dyson spheres. The Infrared Astronomical Satellite, or IRIS, and the Wide Field Infrared Survey Explorer, or WISE, have been used to look for the infrared signatures indicative of Dyson spheres. Important information on star-dimming occurrences has been given publicly by NASA's Kepler mission, which may be used to locate possible Dyson spheres. One such instance is Tabby's star, otherwise known as KIC 8462852, which show peculiar dimming patterns that raise the possibility of extraterrestrial megastructures. This case has prompted more searches for similar anomalies. Breakthrough Listen is a comprehensive program to look for intelligent extraterrestrial communications. It is part of the Breakthrough Initiatives. This study also takes into account the possibility of examining radio and optical signals from far-off stars in order to find technological traces, such as Dyson spheres. Researchers have looked through millions of stars in search of evidence of Dyson spheres, and they have identified 60 potential candidate stars. They span a spectrum of sizes from red dwarfs to sun-like stars with a maximum distance of 65,000 light-years. All exhibit infrared heat excesses that science has not yet been able to explain. Our sun is the most obvious choice to be used in the construction of a Dyson sphere. Because of its proximity and enormous energy output, it is an excellent subject for both theoretical and applied research. Mercury might be the main resource space for building solar collectors or satellites that would create a Dyson swarm around the sun, because it is close to the sun and rich in metals. However, the idea of employing its materials to construct, manufacture, and build a megastructure around the extremely massive sun is still very tentative, uncertain, and theoretical. Nearby stars, including Alpha Centauri and Bernard Star, are also main candidates due to their closeness with the Sun. Some unusual stars, such as Tabby Star and Epic Star, have demonstrated unique dimming patterns that have sparked speculation on potential alien presence. Constructing such huge structures ultimately results in countless challenges and limitations. Gaining energy from stars of the galaxy is actual rocket science. The major challenge is, how do we ensure the stability of all this? In order to avoid collisions and guarantee maximum energy capture, billions of individual satellites or solar collectors in a Dyson swarm must maintain a stable orbit. This requires complicated orbital mechanics and calls for accurate and continual modifications. Heat management is another major concern. Massive amounts of solar energy would be absorbed by the Dyson sphere, producing a considerable quantity of waste heat that would need to be handled. The structure may overheat and become unstable in the absence of efficient heat dissipation devices. It's quite difficult to ensure the structural integrity of such a large assembly. The smallest misalignment or structural collapse in one area could have disastrous results. Technological integration holds few other challenges for megastructure existence. Highly complex robotics and artificial intelligence would be required for the construction and upkeep of a Dyson sphere. These systems would have to function independently, doing difficult jobs for extended periods of time without assistance from humans. Transportation of people and goods into space efficiently is also a major challenge. The scale of transportation required is beyond the capabilities of current rocket technology. And of course, we can't forget about the cost. As of right now, the cost of constructing a Dyson sphere is unimaginable. Resources needed for even a small portion of the project would be well beyond the means of any private company or space agency operating today. The ambition of creating a Dyson sphere may become a reality as humankind's ability to innovate increases, but it will need many breakthroughs that are currently out of our grasp. Are there any other universe enigmas that you find fascinating? Let us know in the comments below, and don't forget to like and subscribe.